Alright, guys. Sorry I had to miss again today, but today is a huge review from what we've already done. So, this first part is just the Pythagorean Theorem. We know a squared plus b squared equals c squared. We're using it to kind of help us orchestrate and balance with this, the distance formula, which we're going to talk about today. So, if we look at our first triangle, they want us to use the Pythagorean theorem to find the length of the hypotenuse. You guys are rock stars at this. We know it. So if we look, our right angle makes this side our hypotenuse because the hypotenuse is always opposite the right angle. So that makes, we've got legs. Okay, so we're just going to count the boxes now. I got 1, 2, 3. So this side length is 3. 1, 2, 3, 4. So this side length is 4. So now we're just going to do our Pythagorean theorem. So it's a squared plus b squared equals c squared. Okay. We're going to substitute the values we know for a and b. So we know 3 squared plus 4 squared equals c squared. Again, we're trying to find that hypotenuse. Sorry that this thing shows up right in the middle of everything. Then we've got, so we get 9 plus 16 equals c squared. So we get, add those two together and it's 25 equals c squared. Okay, so we've got to clear that square, so we're going to do a square root. So we square root both sides, so we know the length of the hypotenuse is 5. Again, guys, hopefully that's more of a refresher. Okay, I'm not going to do too many more of these because I know you guys are rock stars and can handle it. All right, now use the Pythagorean theorem to find the distance between each pair of points. Okay, now it doesn't matter how you draw your triangle, but you know you're going to have a long line here. Oh, can't write in a highlighter. You know you're going to have a long line here, and then you're going to have, I'm going to drop my leg straight down, and I'm going to come across. Of course, if you wanted to, you could have gone over and down. You would have gotten the same answer because of the definition of a rectangle. So now we're going to look. We got to find, so we're trying to find our hypotenuse again. This is our C. We've got to find that one. So we need the distance of each of our sides. This length is 2, whereas our high length is 1, 2, 3, 4, 5, 6. Okay, I'm guessing this one's going to end in a radical. Okay, so we're going a squared plus b squared equals c squared. We are substituting the numbers we know. So 2 squared plus 6 squared equals c squared. Okay, we're going to perform those exponents. So 4 plus 36 equals c squared. Combine our like terms. So 40 equals c squared. We're going to square root both sides. Now, the square root of 40 isn't a perfect square, so it doesn't come out evenly. So we're going to come over here. We're going to do our little factor tree. Because we love factor trees. So we know 40 becomes, I'm going to say 4 and 10. Boom. 4 becomes 2 and 2, whereas 10 becomes 2 and 5. So remember, we're looking for pairs. I've got a pair of 2's, so that means 1, 2 can come out. My other two numbers don't have a dance partner, so they got to stay inside. So 2 comes out, whereas 2 times 5, which is 10, stays in. So the length of my hypotenuse is 2 square root 10. Okay, let's look at one of these word problems. They tell us a 25-foot ladder is leaning up against a building. So the best way to attack this is here's our building, and there's our ladder. Oops. All right, so there's the earth, and then there's the ladder. They told us the length of the ladder is 25 feet, and that the foot of the ladder, which is this bottom part, this is the foot, okay, is 15 feet from the base of the building. So that means this bottom leg is 15. How high? So it wants to know what's the length of this long high side. So again, we've got a squared plus b squared equals c squared. So 15 squared plus b squared equals 25 squared. 15 squared is 225 plus b squared equals, I'm going to think that one's 625, but let's bust out the old calculator to make sure. 25 times 25 is 625. Not 52. Little moment there. Okay. We're going to subtract 225 from both sides, which is different than what we were doing earlier because now we're solving for a leg instead of the hypotenuse. So we know 625 minus 225 is 400. And since we need to get that b squared by itself, we're going to square root it. And we know the length of our building is 20 feet. Okay. That's a 3, 4, 5 family triangle. The first one was a 3, 4, 5. That last one, it didn't have a special right triangle. All right, now let's talk about what we're really going to do today, and that is the distance formula. Okay, so the distance formula we've seen in Algebra 1. We saw it in the first semester. Now we're going to use it again. Find the distance between each point. Okay, and the shortest distance between 2 points is a straight line. And we'll climb any mountain that you want me to climb. The perfect combination is your heart and mine. Sorry, got a little Jody Messina right there. So here we go, guys. The distance formula to find the distance between each set of points. Okay, so we can label from the beginning if that helps us out. So we've got x1, we got y1, x2, and y2. Okay, so the distance formula is the square root. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, now you've got to do your order of operations exact here, guys. You can't go rogue on me. So remember, order of operations. So we got PEMDAS, old PEMDAS. Okay. So you've got to perform the action that's in parentheses first. Okay. Then we'll apply our square exponent, and then we're going to add our 2, and then we'll square root everything. Sounds like a grand old time, right? So x2 minus x1, so negative 2 minus 1 squared plus y2 minus y1, so 3 minus 4 squared. Now the beauty of the distance formula is because distance is always a positive number, we square it because if you square a negative number, it becomes a positive number. Okay? So even though we're fixing to get negative 3 squared plus negative 1 squared, if we remember that we've got to square our numbers first before we add them, we'll be in great shape. If we try to do something else, it's going to mess us up real quick. Okay, so negative 3 squared is 9, and negative 1 squared is 1. 9 plus 1 is 10, and there's nothing else I can do. I'm going to leave it right there. Okay, the distance between 1, 4 and negative 2, 3 is the square root of 10. Okay. Let's do one more, and then I'll set you free. Okay, let's look at 14. 14 looks like a great one. Hey, this time it wants us to round to the nearest 10th. I don't like that as much, but we'll do it because it tells us to. So the first thing we've got to do is identify our 2 points. Remember, we read graphs. Okay, we read them from left to right. So this one is our first point, while this one is our second point. We read graphs left to right. the order won't really affect it here because it'll kind of work its way out. But the better habit we get into, the more successful we'll be for algebra 2. Okay, so this point looks like -1, -1, where this point is 1, 2, 3, 4, 4, 1. So we're going to go distance formula, right? They didn't give us a whole lot of room this time, did they? So the distance formula is equal to x2, so 4, minus x1, -1, squared, plus y2 minus y1 squared. Okay? Double negative makes a, yeah, you guessed it, a positive. So that double negative makes a positive positive, makes a positive positive. So distance equals the square root of 5 squared plus 2 squared, which is 25 plus 4, which becomes the square root of 29. Okay. Now it wants us to round to the nearest tenth, so we're going to put that right in our calculator. And we're going to go 29 and square root, and we get our answer is approximately, I'll round it to the tenth, 5.4. Alright guys, you should have everything you need to be successful. I will see you tomorrow to answer any questions that you may have. Make sure you get your My Math Lab done, and have a great day.